Hi everyone, welcome to our channel Education to All. So today I am going to discuss about spherical mirrors. So spherical mirror is a small part cut from the sphere of a glass. For example, if you have to take one sphere, so this is a glass sphere. You can cut from small parts. So for example, if you cut here and here anywhere, so this small part you can consider as a spherical mirror. So for example, this is a one spherical mirror. Okay. So in the spherical mirrors are two types. That is a concave mirror and a convex mirror. Today I am going to discuss about concave mirror. So in this cutted part, so the bulged surface is called as convex mirror. The bulged surface is called as convex surface, and the hollow surface is called as the concave surface. So finally, a spherical mirror is a small part cut from a hollow sphere of glass. So this is the small part of a glass sphere. So the bulge surface is called as the convex surface. Hollow surface is called as the convex surface. Next, concave mirror. So concave mirror means nothing. The reflecting surface is inward. It is called a concave mirror. So for example, this is a concave mirror. So this is the bulged surface. So that means here polished surface is there. So this inner region is the reflecting surface. For example, the light rays is fall onto the mirror. For example, parallel to the principal axis. After reflection, it will be reflected back. So for example, if we take one more incident ray, so this ray is also reflects like this. So these two reflected rays met at some other point. So that is called as the converging mirror. So that we can say that the reflecting surface is inverse, and at the same time this is also called as the converging mirror. Next, convex mirror. So convex mirror means nothing. The reflecting surface is outwards. The reflecting surface is outwards is called a convex mirror. It is also called as the diverging mirror. So why? Because so the incident rays is fall onto the mirror like this. Two rays are travel parallel to each other. After that, it reflected ray is diverges. This reflected ray is also diverges. So that it is called as the diverging mirror. So convex mirror or diverging mirror is same. The reflecting surface is outward is called a convex mirror. The reflecting surface is inwards is called as a concave mirror. Next, terms related to the spherical mirror. So terms related to spherical mirror, the first one is pole. So pole means nothing. The point on the mirror at the middle of the surface is called the pole. For example, if you take any one mirror, so for example I am going to take a concave mirror. So in this concave mirror, the pole is located at center of the mirror is called the pole. At the same time, convex mirror, the convex mirror is this is the pole is located at the center of the mirror. This is the pole. Next, center of curvature. So center of curvature means nothing. The center of a sphere which the mirror is a cut from the center of curvature. So for example, so how can you prepare the convex and concave mirror? We are going to take one spherical glass. So that is the glass sphere has center here. So if we are going to cut from here, so we can get the one mirror, that is the concave mirror. So the center is located at the outside, inside of the mirror. For example, this is the center of the curvature. So simply you can say that the center of the sphere of which the mirror. So this is the center of the sphere which the mirror is a part is called the center of curvature. So this is the this. Next, convex mirror, the center is present outward. For example, the center is located here. So the next one is radius of curvature. So the distance between the center to the pole. So this is the pole. the distance between the center to the pole, the distance between the center of curvature to pole of the mirror is called the radius of curvature. The radius of curvature is represented as capital R. So this distance is capital R. Next, principal axis. So principal axis means nothing. The line joining the pole and center of the curvature is called the principal axis. So this is a pole, this is the center. The line joining from pole to center is called a principal axis. One is a principal focus. For example, we have to take one concave mirror. So in that concave mirror, has the center and pole. So line joining from the center to the pole is called the principal axis. The principal focus is exactly located at the center between the pole and center. So that is, it is a point on the principal axis. Where the beam of light parallel to the principal axis after reflection either actually meet or appear to meet. It is denoted by capital F. So that means simply we can define as the focus is located between the pole and center, or when the rays of light passing parallel to the principal axis after reflection, it be reflected back into the same medium. This is also reflected back. So these two rays are met at a point. That point is called the focus. So we have two definitions. One is depends on the wave propagation. Another one is that it is between the pole and center. Exactly between the pole and center is called the principal focus. Next, focal length. So focal length means nothing. The distance between the pole to the focus. Is called the focal length. So that is the distance between the focus from the pole of the mirror is called the focal length of the mirror. Same convex mirror also same. In that convex mirror also same. The distance between the focus to the pole is called the focal length. Next, normal. The line joining the point of incidence and a center of curvature is known as the normal at that point of incidence. Take one concave mirror. So this is the concave mirror. Concave mirror has center. This is the center. This is the focus. This is the pole. So when the light rays is passing either parallel or passing through the focus, whatever it is, no problem. So from the point of incidence, so this is the point of incidence. From this point of incidence to the center, we can draw a one line. So this is the normal. So what the line joining the point of incidence, and center of curvature is called the normal. Okay. Next, marginal rays and paroxial rays. Paroxial rays. So paroxial rays means nothing. The rays which are close to the principal axis. For example, we take one concave mirror. So in this concave mirror, this is the principal axis. The rays which are close to the very close to the principal axis is called as the paroxial rays. The rays which are very close to the principal axis. So this is the principal axis. So the rays which are very close to the principal axis is called a paroxial rays. Next, marginal rays. The rays which are far away from the principal axis. The rays. So this is one concave mirror. So in this mirror is a concave mirror, principal axis. The rays which are very far away from the principal axis is called a marginal rays. The rays which are far from the principal axis is called a marginal rays. So one note point is there. So that is in the case of paroxial rays. The aperture of the mirror is negligible. Aperture of the mirror. So for example, this is the mirror. So this mirror aperture is negligible, and angle of incidence is approaches to 0. So that means angle of incidence is nearly 0. The angle of incidence it is negligible. So the angle of incidence is nearly is equal to 0. So next another one is, in this lesson we shall consider only paraxial rays. So we can consider only paraxial rays, not marginal rays. They form a nearly point image in a point source. So we are considered as only point source. The point source forms the point images, so that we consider only paraxial rays, not a marginal rays. Next, image formation due to a spherical mirror. Image formation due to a spherical mirror. So that is, the first one is, the position of image and its nature formed due to a spherical mirrors depends on the distance. Depends on the distance of the object. For example, if we have to take one mirror, so the object is placed at infinity distance. So the nature of the image is something. The object is moves towards the mirror. The object is moves towards the mirror. The nature of the image is also changed. So that is the first one. Next, the second one is, to locate the position of image, we draw two rays from the object, make them incidence on the mirror, and trace the reflected rays. The point of intersection of the reflected rays gives the image of the object. For example, we have to take the one mirror. So that mirror is placed at infinite distance. So from the infinite distance, it can take any two rays. One ray is passing parallel to the principal axis. Another ray is passing through the center of the mirror. Center of curvature of the mirror. So, for example, after reflection, it will be travel like this. So it is travel like this. These two rays are met at some other point. That point of intersection is called the image formation. Next, third one is, in information about the image can be obtained either by drawing a ray diagrams. So by using ray diagrams, you can find the nature of the image, and by using formula also you can find the nature and position of the image. So the first rule is, a ray through the center of curvature which strikes the mirror normally and reflected back along the same path. For example, if in a concave mirror, the light ray is passing. The light ray means the incident ray is passing or traveling through the center. So this is the incident ray. So after reflection, it should be passes or travel or reflected back into the same path. So this propagation, this line is called as the normal. So that you can say that a ray through the center of curvature which strikes the normally. Normally means here makes the 90 degrees. Normally reflected back into the same path. At the same time, convex mirror also, when an incident ray is passing, appear to pass through the focus, at the reflected ray, it should be reflected back into the same path. So it is applicable for both convex and concave mirror. So this is the first rule. Second rule is, a ray parallel to the principal axis after reflection either actually passes through the principal focus, or appear to passes through the principal focus. For example, if you have to take one incident ray, the incident ray is passing parallel to the principal axis after reflection from the point of incidence. This is the point of incidence. From the point of incidence, it will be reflected back. So through it, which one? Where? Through the focus. So when the light ray is passing parallel to the principal axis, after reflection, it should be passing through the focus in a concave mirror. At the same time, in a convex mirror also, an incident ray is passing parallel to the principal axis. After reflection, it is appear to. So this is the incident ray, this is the reflected ray. So this reflected ray is a diverging ray. So this diverging ray, so means the reflected ray can extend like this, means it is appear to pass through the focus. So in a convex mirror. So this is the second rule. The second rule is, a ray parallel to principal axis passing through the parallel to principal axis. After reflection, it should be passing through the focus or appear to pass through the focus. Next, the third one is, a ray passing through the principal focus. A ray passing through the principal focus after reflection it is appear to passing parallel to the principal axis, or it converges passing to the principal axis, whatever it is. So a ray passing to the principal focus after reflection from the point of incidence, it will be reflected back. It is travel parallel to the principal axis. So in convex mirror, a ray is appeared to pass through the focus after reflection from the point of incidence. It will be reflected back from where? From the point of incidence parallel to the principal axis. So this is the third law. Next, a ray striking at pole P. A ray striking at pole P. So that means a ray passing through the center and focus and strikes at pole P is reflected symmetrically back into the opposite direction. So that means it will be reflected back into the same path. So here also a ray striking at a pole P, and after reflection from the pole it will be reflected back in symmetrically in the opposite direction. This is the ray rules for 4. So generally, frequently we are using these 4 rules. By using these 4, we can form the image on the mirrors.